vision.
One community. One assailant.
Good afternoon, Philippines.
It's January 23rd, 2021.
We hope you are having a great day.
This is Observing the Sky Network, bringing you the top news. That are surely with no bias for the details of our news.
We have here today Duncan Brown J. Charles, Professor of Physics in Syracuse University and part of the team that made this historic discovery happen. And Duncan, how exciting was that?
It was pretty exciting. This has been a very exciting moment for all of us involved.
Well, last month, researchers at your university detected a gravitational wave from the collision of two neutron stars on Monday, and that they were able to locate from that collision. And what is the significance of that collision?
So what this observation means is that we now know where the gold and platinum in the universe comes from. I'm wearing a wedding ring right now that's made of platinum, and we've seen the universe create that platinum in the collision of these two neutron stars.
It's really mind-boggling to imagine this right now. We are showing viewers the NASA animation here. LIGO also detected gravitational waves from the collision of two black holes in August. Explain for us here what's the difference.
So black holes, as their name implies, are black. When they collide together, they make a giant ripple of gravitational waves, but they don't emit any light. Neutron stars are two city-sized atomic nuclei. They're the remnant of dead stars, and when they collide together, okay, so you take a star, it burns away its nuclear fuel, it collapses down, and it produces this ash called a neutron star, which is 1.5 times the mass of the sun, packed into a ball about the size of Manhattan. You smash two of these things together at 1/3 the speed of light, and you get gravitational waves given off, and you get light given off. All types of light, from gamma rays down to radio waves with visible light. So we've actually taken pictures of this collision. We've not just heard the gravitational waves, felt their vibrations, we've seen the light from this collision with telescopes.
This is so fascinating. But those gravitational detection combination from electromagnetic telescope, even NASA satellite. Can you explain a little bit more how that happened and sort of ripple effect as it spread the word of this of all science in this world? Basically, essentially coordinating and training their instruments in this one place, in this massive universe of ours.
That's right. So LIGO and Virgo, the gravitational wave detectors, they feel the ripples in space-time, and they can tell you where on the sky this source is coming from. The sky's a really big place, and telescopes can't see much of the sky, so they need to be told exactly where to look. And so using the gravitational waves, LIGO and Virgo, our French-Italian partners, and the LIGO observatories in the US, we told the astronomy community, hey, look here. We think there are two neutron stars colliding right here in the sky. The astronomy community leapt on it, pointed telescopes, scanned that patch of the sky, and they saw the afterglow, they saw the light given off by this collision.
Incredible! The collision traveled outward with the speed of light, more proof of Einstein's theory of general relativity. So where does this leave physics in astronomy? What comes next here?
So this is really just the beginning. I mean, 400 years ago, Galileo pointed his telescope at the heavens and made the first observations with telescopes using light. We're only just making the very first observations of the universe with gravitational waves. With gravitational waves, we can see into the cores of exploding stars. We can see these black hole collisions, these neutron star collisions. And as our detectors get better, we might be able to see further back in time to the beginning of the universe and be able to take pictures of the beginning of the universe.
Well, that was a marvelous intellectual interview with physics professor with Duncan Brown. Now we are moving to the topic of nebulas with Catherine Cadet, about her experience witnessing it with her own naked eyes. Good afternoon, Catherine. Can you hear me? You're in Ohio, am I correct?
Yes, and it's so nice to be in network today. Before seeing the beauty and wonders of Orion's Great Nebula, let me lay out a few nuts and bolts facts. The Orion Nebula is classified as an emission nebula, a cosmic cloud of gas and dust that shines by its emitting its own light. Recent studies place its distance at about 1,300 light years.
And its apparent size of 1.5 and 1 degree translates to a true diameter of some 25 light years. Correct?
Certainly, yes, and the nebula's discovery is credited to the French astronomer Nicholas Perisek, was spotted in 1610. Charles Messier observed and catalogued it the night of March 4, 1769, designating it M42.
This is OTSN, and we'll be right back for a shortly break.
This is a totally sponsored video.
Yes, you. You want to learn more about space as much as I do? If by any chance you were intrigued by our lesson here, you were amazed, and perhaps you want to learn more, well, I've got you covered. And I have something for you, and it's brilliant. No, I'm not using it as an adjective, it's literally called brilliant. Brilliant is a quantitative building skill website based off mathematics, science, computer science, all that stuff. It's a website designed for you to learn more about these kind of subjects. In other words, it's an educational website where you can learn more about science, math, computer. But there's a catch. You'll learn it in a more interactive and challenging way. And for the most part it's free. And even if it was paid, it's cheap. So you don't have to worry about your pocket getting empty. If you want to learn more about quantum mechanics, if you want to learn more about general relativity, if you want to learn about the golden ratio, all that stuff, Brilliant has it covered. And then Brilliant will turn you brilliant in no time.
This is OTSN, and welcome back. Alkyra talking, and Catherine, you may continue.
A naked eye view of the Orion Nebula from the dark side allows us to admire its namesake constellation, or could be the greatest of all.
Such a view. The telescope is placed at the Orion Nebula's at the center stage, right?
A telescope places the Orion Nebula at center stage, no computation from constellations or immediate surroundings. Even a common 2.4-inch refractor in magnifying at just 13 times to 15 times captures impressive details.
The visual impact of Orion Nebula is so overwhelming that we initially overlook an amazing little quartet of stars that were embedded in the nebulosity and the best seen with a magnification of 75 times to 100 times. This is Trapezium, a tight cluster of stars birthed by the Orion Nebula. Such perfection. Oops, looks like our time is up. Thank you so much, Catherine, for showing us your video and giving us insights.
And those were our top stories for this hour.
This is Otsn, vanguard of radical change in science. This has been your unbiased and truth of orders, Aljun Nabua.
And Amina Makasinjil, saying we do not just spread insights,
We do not lie and we say the truth to the people.